In this section, I will look at name resolution. Name resolution is used by computers on your network to find computers and services on your network. Names are easier for humans to remember than numbers, and thus name resolution is essential for networking. In this video, I will first look at NetBIOS. NetBIOS is a network protocol that was developed back in the 1980s. It has since been superseded by TCP/IP. Even so, NetBIOS is provided for backward compatibility with older applications. Next, you have host names, which are the DNS equivalent of NetBIOS names. Once you have an understanding of where NetBIOS names and host names come from, I will then look at the computer name. Which system is being used will determine which name will be used for the computer name. Next, I will look at the name resolution process. Every time you type in an address or a computer name, a process is followed to determine the IP address. You need to understand this process so that when you are troubleshooting networking problems, you will know where to start looking. After this, I will look at the WINS server. WINS is the name resolution system for NetBIOS names. It is similar to DNS, but is being phased out. Next, I will look at broadcast resolution. This is the process of looking for hosts on the local network by sending a broadcast on the local network with the hope the host responds to the request. Lastly, if all else fails, there is the LMHosts file. The LMHost is a text file that contains NetBIOS names and their IP addresses. There is also a host file, which I will look at, which is used by DNS. This should be enough theory for you, and I will perform a demonstration of how to set the client settings on Windows Server 2008 Release 2. This will show you where to find the settings in Windows and how to configure name resolution. Finally, I will look at troubleshooting problems with name resolution. If networks were static, name resolution would be a lot easier. Unfortunately, networks change, and because of this, when your client performs name resolution, you may get the wrong results. I'll show you what to do when this occurs. NetBIOS is a network standard that was first developed back in the 1980s. Even though TCP/IP has become the default protocol on the internet, and you would be hard-pressed to find a network that runs the NetBIOS protocol, some old applications still need NetBIOS. The NetBIOS name is 16 characters in length. The name itself is limited to 15 characters. The last character is used to identify the service type. NetBIOS names were used back in the Windows 95 and DOS days. When Windows 2000 came out, Microsoft started phasing out NetBIOS names in favor of DNS. The big disadvantage of NetBIOS names is that the namespace is flat. If you attempt to name two computers on the same network with the same NetBIOS name, even if they are in different domains, you will have a conflict. NetBIOS has some great features, some of which were not available in DNS at the time. With the improvements in DNS, DNS has all the features NetBIOS had plus more. For these reasons, NetBIOS is being phased out and replaced by DNS. With the introduction of DNS, a computer can also be identified by its host name. The host name is up to 255 characters in length. The host name forms part of the fully qualified domain name. This means you can include a domain name with the computer name. With the introduction of the host name and DNS, the namespace is no longer flat. For example, you could have the computer name DC1 registered in both the example.com domain and the test.local domain. Using host names, both these computers could exist on the same network, even at the same site, and the names would not conflict with each other. This brings up the question of what is a computer name. Is it the NetBIOS name or the host name? To help your computer be compatible with older software, Microsoft allows you to set a NetBIOS name and a host name. For example, in this case, the computer will have a NetBIOS name of DC West and a domain name of Extreme. Notice also with NetBIOS, the domain name can only be up to 15 characters in length. With DNS, the domain name and host name can be up to 255 characters. With DNS, you can also use characters in the name that can't be used in NetBIOS names, such as hyphens. DNS is the default method of name resolution in Windows Server 2008. What happens when you join your computer to a domain? Windows will set a NetBIOS name for your computer and a NetBIOS domain name. On most networks, you may not even be aware that a NetBIOS name exists for the computer. This is done for backward compatibility with older software. If you are sure that none of the software on your network requires NetBIOS, you can disable it. If you decide to do this, make sure you do your research first. Software such as Exchange Server 2003 still required some NetBIOS services on the network to function. However, software released in the last few years should not require any such services. Host names are essentially there to help humans. Computers work in the world of numbers, aka IP addresses. To change a host name into a number, Windows uses a resolution process. Before a computer can route a network packet from one location to another, the destination must be converted from a host name into an IP address. Host name resolution is the process of resolving a name to an IP address. Windows has 3 different ways of resolving a host name to an IP address. These are DNS, Link Multicast Name Resolution, or LLMNR, and NetBIOS. Windows will favor DNS in resolving host names. However, on a network without a DNS server, or when the DNS server does not have a record for that host address, a different method of host resolution must be used. A simple example of this is if you were in a coffee shop using a wireless network and wanted to connect to a friend's laptop. There is no DNS server on the network that will support dynamic updates, so Windows must have an alternative way of locating your friend's laptop. There is a lot that can go on to resolve a host name to an IP address, and a lot of different systems that can be involved. To try and understand the process better, I will go through the default process used by Windows to resolve a host name to an IP address. First, the computer will check the local DNS cache to see if the address has already been resolved. One thing I would like to point out is that the DNS cache not only holds any previously resolved DNS entries, but also holds the contents of the hosts file. The hosts file I will look at later, but essentially it is a text file that holds host names mapped to IP addresses stored on the local computer. If the request cannot be resolved from the DNS cache, the computer will contact its DNS server. If the DNS server cannot resolve the name, the computer will then check the NetBIOS cache. If the host name cannot be resolved in the NetBIOS cache, Windows will then contact a WINS server. I will cover WINS in more detail later on, but for the present, think of it as the NetBIOS implementation of DNS. Since WINS is being phased out and being replaced by DNS, it is possible you may not have a WINS server on your network. If the name cannot be resolved by the WINS server, the computer will then send out a broadcast. A broadcast sends out a message to the computers on the local subnet trying to find the IP address for the host name it is trying to resolve. If the computer is on the local subnet, it should respond to the request. With Windows Server 2008, this is performed in 2 different ways. The first is LLMNR. LLMNR I will cover in more detail later on, but essentially it is a multicast resolution system for IP version 6. If Windows cannot resolve the host using LLMNR, it will attempt to resolve the host using a NetBIOS broadcast. When a NetBIOS broadcast is used, all computers on the local subnet will receive the broadcast. This is not an efficient method to resolve host names, and some administrators will switch off NetBIOS so broadcasts like these are not sent out on the network. If no computer responds to the broadcast, the client checks its local LMHosts file. The LMHosts file is a file stored on the local computer. Later on, I will have a closer look at the LMHosts file, but essentially it is a text file that contains NetBIOS names and their IP addresses. As you can see, there are a lot of different systems that are involved in resolving a host name to an IP address. Because of this, troubleshooting host name resolution issues can be difficult. The WINS server, or Windows Integrated Naming Services, maps NetBIOS names to IP addresses. It does this using a flat namespace, which is the biggest disadvantage of WINS. This means you cannot have 2 computers with the same name using the same WINS infrastructure. This makes WINS not very scalable. Wins dates back to the Windows NT days and, at the time, addressed some shortfalls of DNS. The most noticeable of these features was dynamic updates. All the features that Wins has that DNS did not have at the time are supported by DNS today. The result of this is Wins is being phased out. Back in the Windows NT days, it was not uncommon for each site to have its own Wins server. These Wins servers were kept up to date via a push-pull replication system. When administrators design networks these days, most administrators will try to not deploy any Wins servers if possible. One large site I did some work on had one Wins server for the entire network, which was spread out over multiple sites. The Wins server was only there for backward compatibility. The administrators felt that it was not worth setting up an internal replication system for Wins when it was rarely being used. On the odd chance it was needed, they were happy for the network traffic to travel over the WAN link to reach the Wins server. If I were setting up a new network, I would attempt to set up the network without a Wins server. If I later discovered it needed one, I would simply add one starting small and adding more Wins servers only if needed. I will go through a few of the client settings for Wins later on, but for the exam, you only need to have a very basic understanding. Microsoft likes to test you on their new technology. It is extremely unlikely that they will ask you a question directly related to Wins. If you do have a Wins server on your network and it is configured and it can't resolve a name request, Windows will then try broadcast. When broadcast resolution is used, the request is only sent to the local subnet. When DNS and Wins fail to resolve the request, Windows will attempt to send out a broadcast to resolve the request. This works well when you have a computer that is on the same subnet. This also works when the computer is in a different domain on the same subnet, or you have computers that are attempting to communicate with each other but do not have any DNS infrastructure. For example, when you have a home network. If NetBIOS is used, a broadcast will be sent to the local subnet using IP version 4. All computers on the subnet will receive the broadcast. If Windows uses link local multicast resolution to resolve the requests, it sends a multicast packet rather than a broadcast. This results in a lot less traffic being sent on the network. LLMNR supports both IP version 6 and IP version 4. However, IP version 4 may not be enabled. Generally speaking, Windows uses NetBIOS for IP version 4 resolution and LLMNR for IP version 6 name resolution. In order for LLMNR to be used, the computer you are trying to find must have Network Discovery switched on. If Network Discovery is not switched on, the computer will not respond to the request. Network Discovery was first introduced in Windows Vista. If you are running Windows XP, it can be installed. Having said this, Windows XP will only answer requests from other clients. On Windows Vista and above, Network Discovery can be used to discover other computers on the network. Even with the additional software installed, however, Windows XP will not be able to discover other computers on the network using LLMNR. If broadcast resolution fails, Windows will check the LMHosts file. This file is a text file that contains NetBIOS names and their IP addresses. This is stored in the system root system32 driver etc folder in the file LMHosts. In most networks, you will never need to use the LMHosts file. It is not recommended to use the LMHost file when it can be avoided, as changes need to be made manually in the file. Imagine a large network of computers and you had to update a file stored on the local computer each time a change was made. In the past, I have used LMHosts in very special cases. For example, when a computer needs to resolve another computer that is part of a different branch of the company that is managed by a different IT department. For one-off service, often it is difficult to make changes to the DNS infrastructure to correctly resolve the name. This can be a nightmare in larger companies with many different IT departments. For one user needing to access one server for a piece of software that is rarely used, it may be easier to simply make a change to the LMHosts file. However, when possible, I would recommend making the changes to a DNS server. To better understand how client resolution works, let's go through some of the settings in a Windows Server 2008 Release 2 install. First of all, I want to have a look at the DNS setting on this system. To do this, I will open the control panel and select the option View Network Status and Tasks. This is a great screen to give you a quick rundown of your network. On this screen, you can see how many network adapters you have installed and what networks they are attached to. In this particular case, I only have one network card. If I select this network adapter and then select the Properties button, you can see all the services and protocols that are bound to this adapter. In this particular case, I want to look at the DNS settings. In this example, I will go through the settings for the IP version 4 protocol. I won't worry about the IP version 6 protocol, as the DNS tab for it is almost identical to the version 4 tab. On the General tab, you can see that the DNS server has been manually entered. To access additional DNS settings, select the Advanced button. Once in the Advanced section, select the tab DNS. The top section has DNS entries for this adapter. Notice that there is room to add more than 2 DNS servers here if you wished. It is rare to have a computer that has more than 2 DNS servers, but if you need more redundancy, you can add additional ones. Just remember that when you attempt to resolve a DNS name, Windows will contact every single one of the DNS servers when attempting to resolve the request. If you entered in 10 DNS servers, for example, these are 10 servers Windows will attempt to contact to find an answer to your query before it moves on to the next resolving step. The next option, Append Primary and Connection-Specific DNS Suffixes, means the primary and connection suffix will be appended when only the hostname is given. For example, if I open a command prompt and ping DC1. You will notice that test.local has been added to DC1. Test.local is the primary domain suffix for this domain and will be appended to any resolve request that only contains the hostname, like this one. If I go back to the advanced settings, you will notice the setting DNS suffix for this connection. This is down at the bottom of the advanced screen. This allows you to set a different suffix for each connection on your computer. The next option, Append Parent Suffixes of the Primary DNS Suffixes, is a bit of a mouthful. To understand how this works, I will open the System Control applet from the Start menu. I want to access the computer name settings, so I will select the option at the bottom, Change Settings. From here, select Change to take you to the settings for the computer name, and then select the More button. Here you can see the DNS suffix test.local. This is the primary DNS suffix that is being added on to each host I try to resolve. To understand how the other option works, I will change the suffix to west.lab.test.local. This shows the primary DNS suffix does not have to be the same as the domain. Only in special circumstances would you want to change this. For the purpose of this example, I won't reboot the computer when prompted to. If I now go back to the advanced settings, the Append Parent Suffixes to the Primary DNS Suffix makes more sense. What will happen when I attempt to resolve a hostname like DC1? With this example ticked, the client will do the following. It will first attempt to resolve dc1.west.lab.test.local. If this fails, it will then attempt to resolve dc1.lab.test.local. Notice that the West part of the name has been dropped. If this fails, the client will attempt to resolve dc1.test.local. With this option ticked, the DNS suffix is reduced each time a host name can't be resolved until it is down to 2 parts. It is not reduced any further, as that would no longer be a proper domain name. The next option, Append These DNS Suffixes, will append the DNS suffixes that you enter in the order that you enter them. If you want complete customization of the suffixes that get appended, select this option and enter in the suffixes that you require. The option Register this connection's address in DNS basically enables or disables dynamic update for this computer. If I enable this option, the computer name and suffix in the system control panel will be registered in DNS. The last option, if ticked, will register the DNS suffix for this connection in the DNS server as well. In this case, the above suffix, extremetraining.local. Ticking both these boxes will result in 2 DNS entries being added to DNS. If I now click on the Wins tab, I can set the options for the Wins servers. First of all, I can enter in some Wins servers if I have them installed on my network. I don't have a Wins server on this network, so I won't worry about this. Notice the option Enable LMHosts Lookup. If this option is ticked, the last part of the resolving process will check the LMHost file to see if this contains an entry. The next setting determines if NetBIOS will be used in name resolution. This is referred to as NetBIOS over TCP/IP. The first setting will be set by the DHCP server, or when a DHCP server is not being used or not contactable, it will enable NetBIOS over TCP/IP. NetBIOS is a networking protocol that allowed small networks to communicate and was not routable. Because of this, it was replaced by TCP/IP. However, some of the features of NetBIOS were still required, and this is where NetBIOS over TCP/IP was born. NetBIOS over TCP/IP allowed a non-routable protocol like NetBIOS to become routable, and allowed some of the features of NetBIOS to continue to be used on large networks. If you select this option, NetBIOS over TCP/IP will be used regardless of which setting is used on the DHCP server. The last setting will disable NetBIOS over TCP/IP. If you are sure you no longer require NetBIOS on your network, you can disable this. Personally, I would leave it on the default setting and enable or disable it from DHCP. This gives you the most control. This covers the basic DNS and Wins settings. If I close out of the network settings now, I'm going to go through the LMHosts and hosts files. These are found in the Windows, System32, Drivers, etc. directory. The host file is loaded in the cache of the DNS client. In other words, it is checked first. The LMHosts file is checked last. If I open the hosts file using Notepad, you can see there are a lot of comments in there and some examples. You can see down at the bottom the example used for localhost with an IP version 4 address and an IP version 6 address. Since the pound sign is at the start of the line, this will be considered a comment and will not be loaded. You can see in the localhost example, you only need to enter in the host name. The host file does not require a fully qualified domain name. You can also see some other examples that Microsoft has provided. If you want to add a fully qualified host name, you can. Sometimes when I want to redirect a test client to a test server, I make changes to this file so I don't affect the production environment. Editing host files like these stored on the client computer can become very labor-intensive very quickly when a lot of computers are involved. The host file only applies to DNS-related records. If you want to add NetBIOS records, you can add these to the LMHosts files. You can see in this directory the file lmhosts.sam. This is an example file and not the LMHosts file. In order to start using LMHosts, copy the example file and then rename it so it does not have an extension. You can see now I have a file called LMHosts. If I open the file in Notepad, you can see the file has a lot of comments. If I scroll down toward the bottom of the file, you can see in the middle there are some examples. First, you need to enter in the IP address. The next thing you need to enter is the NetBIOS name. This is subject to the 15-character limit. If you need to enter in a name that is longer than 15 characters, you will need to use the host file, which will not be compatible with NetBIOS. The option #pre means Windows will preload the entry into memory. If you do not add the #pre option, name resolution will fail, after which Windows will load the file to see if there is an entry. It is recommended that you use LMHosts and hosts file as a last resort. Starting with Windows Vista, Microsoft introduced LLMNR to help resolve computer names to IP addresses. To have a look at how these work, I need to first go back to the Networking and Sharing Center. From here, I need to select the option Change Advanced Sharing Settings from the left-hand side. From this screen, you can see that Network Discovery is switched off. For your computer to discover other computers and for it to allow itself to be discovered, Network Discovery must be switched on. Once I save the change, I can go back to the Network and Sharing Center. From here, I can select the option See Full Map. This will generate a map of the network. I will receive a message saying that network mapping needs to be enabled. To fix this problem, I will run the Group Policy Editor from the Start menu. This will allow me to edit the local group policy on this computer. The group policy that I am interested in editing is under Administrative Templates, Network, and Link Layer Topology Discovery. The first group policy setting allows this computer to map out resources on the network. With this setting enabled, the computer will be allowed to send multicast packets on the network to discover other computers and devices on the network. This group policy setting only applies to the mapping. The second group policy setting applies to the responder. The responder is the service that provides an answer to network discovery requests when the client receives them. Without this option on, the computer will ignore any network discovery requests. If you want to map out your network, you will need to ensure that every client on your computer that you want to answer the requests has this group policy setting enabled. Once I finish editing group policy, I need to close it and then run GP Update. This can be run from the Start menu. GP Update does take a few seconds to run. Once complete, I can then go back and select See Full Map, and it will start querying the network. This usually only takes a few seconds to run. Once complete, you will be shown a diagram of what your network looks like. Items on your network may not appear if they first, do not support network discovery, or secondly, are not configured to respond to network discovery messages. As you can see, it is a useful tool for seeing the topology of your network if your network supports it. With so much involved in name resolution, something is bound to go wrong. When this happens, you will need to know which tools to use to fix it. The ipconfig command has a number of switches that can be used to help troubleshoot DNS-related problems. The first is flush DNS. If you run ipconfig/flush DNS, the local cache is removed from the computer. When a client resolves an IP address, it will remain in the cache, so it does not have to query the DNS server again for that data. If the IP address changes, however, the client will still be using the cache entry for a period of time. When this occurs, you can use this command to remove the old entries. If you change the IP address on the local computer, you may find the DNS server on the network now has an incorrect entry for your computer. Eventually, your computer will re-register itself with DNS and the problem will be corrected. However, if you want to speed up the process, run the command ipconfig/registerdns. This will force the client to update its DNS record on the server. You will notice here that the server will give you a message saying an event will be logged in the event viewer in 15 minutes if there was a problem. Registered DNS is pretty fast, so after you run it, assuming that there were no problems updating your records, the DNS servers on your network will be updated within a few seconds. Next, there is the command ipconfig/displaydns. This will show all the cached records on the local machine. As you can see, there are no records displayed because a DNS flush was just run. In order to get some records in the cache, I will ping DC1. In order to get the IP address of DC1, the client must contact the DNS server. If I run the command ipconfig/displaydns again, you will notice that now I have some entries in the local DNS cache. The last troubleshooting command I want to look at is nbtstat. This gives you information about NetBIOS. If I add the N switch, This will show the records that are registered for the local computer. You can see for this computer there are 3 records. The first record is 00, which is for the workstation service. The next one, test, is for the domain of which it is a member. The last record, 20, means this computer supports file sharing. As you can see, the DNS types tell other computers on the network what services this computer has. Having said that, DNS can perform these functions, and this is one of the reasons why NetBIOS is hardly used anymore. When looking at client resolution, make sure that you understand the name resolution process. When troubleshooting name resolution problems, either on a production network or in the exam, you will need to understand which systems get tried in which order. A system that gives back a stale or incorrect entry will send the client to the wrong IP address. Remember that NetBIOS and WINS are being phased out. You may not need them at all for your network, but before you decide to switch them off, make sure none of the software on your network requires them. Make sure that you have a well-designed DNS infrastructure, as DNS is the name resolution technique of choice. It is the choice of the Internet and Active Directory. Lastly, remember that LLMNR is primarily used with IP version 6. It can be used with IP version 4, but most operating systems will have this switched off. Remember, when troubleshooting client resolution problems, look at the process involved and go step by step through it until you find the problem. Good luck with name resolution. It is an important thing to understand for your production environment and for the exam.